Hey everyone, welcome back to Maths Nation. Today we'll be going through the 2024 June Paper 3 Calculator Higher Tier paper. We'll be going through each and every question step by step to make sure that we get full marks. Let's get into it. Question 1 is asking us to find the highest common factor of 63 and 105. So what we're going to do is we're going to find all the prime numbers that multiply to give 63 and 105. So starting off with 63, we know that 63 is 7 times 9, and 7 is a prime number, so we're going to circle that. And then 9 can be made up of 3 times 3. And 3 is also a prime number, so we stop there. If we do the same thing for 105, dividing by 5, you have 5 and 21, and 5 is a prime number. And then 21 is 7 times 3, both of which are prime numbers. So we ask ourselves, which numbers do both 63 and 105 share? Well, we have 7, 7, 3, and 3. And so to work out the HCF, it's 7 times 3, which is 21. So the highest common factor is 21. Question 2a, part 1, asks us to write 5.3 times 10 to the power 4 as an ordinary number. So right now we're in standard form, and the indice is 10 to the power of positive 4, and so we move the decimal place to the right. So we have 5.3, we're going to move it 4 places to the right. That's 1, 2, 3, 4. And so our new number is going to be 53,000. Part 2 says, write 7.4 times 10 to the power of negative 5 as an ordinary number. Now that we know that the indice is negative, we're going to move the decimal place to the left-hand side. So 7.4, and we move it to the left-hand side 5 times. 1, 2, 3, 4, 5. So 0.00074. Part B asks us to calculate the value of 9.7 times 10 to the power of 6 plus 2.45 times 10 to the power of 7, giving your answer in standard form. Well, both have positive indices, and so we're going to move the decimal place to the right hand side. So that's 9.7, and then we move the decimal place to the right 6 times. 1, 2, 3, 4, 5, 6, and that gives us 9,700,000. We do the same thing for 2.45. I'm going to move the decimal place to the right hand side 7 times. 1, 2, 3, 4, 5, 6, 7, and that gives us 24,500,000. And if we add both of these together, we get 34,200,000. And finally, we need to put this into standard form. And so we need to move the decimal place until the first number is a non-zero number, in our case 3. So the decimal place is here, 1, 2, 3, 4, 5, 6, 7. And so the number becomes 3.42 times 10 to the power of 7. Question 3 says, the diagram shows a solid triangular prism. Rana is trying to draw the side elevation of the solid prism from the direction of the arrow. Here is our answer on a centimeter grid. Explain why Rana's side elevation is not correct. Well, from the direction of the arrow, the side elevation is this here. And so Rana is saying that this length here is equal to this length here, and as it's a centimeter grid, she's saying it's 4 centimeters. Well, that can't be right, and we're going to use Pythagoras' theorem to show why. This length here is going to be half of 6, which is 3, and so Pythagoras' theorem says a squared plus b squared is equal to c squared, where c is the hypotenuse. We'll keep a as the unknown. A squared plus the b, which is 3 squared, is equal to 4 squared. That's 3 squared equals 9, and 4 squared equals 16. If we rearrange to make a the subject, we have a squared is equal to 16 minus 9. A squared is equal to 7. And so square rooting both sides, we have a is equal to root 7, which is not 4. Part B says, on the centimeter grid below, draw a plan of the solid prism. So if you look back at our prism, a plan is going to be a bird's eye view if we're looking down. So if you're looking down, we have a length this way and down, so a rectangular shape. And this is going to be 7 centimeters, which represents this side here. And this is going to be 6 centimeters to represent this side here. And we know that we have a cut in the middle, halfway. And so if we draw this onto our centimeter grid, we have 1, 2, 3, 4, 5, 6, and 7, and then 6 down. 1, 2, 3, 4, 5, 6 down. And so if we join that up, like so, and then we know we've got a line in the middle at 3 centimeters. So that's 7 centimeters by 6 centimeters. Question 4 says, a company has 25,000 workers. The number of workers increases at a rate of 6% per year for 3 years. Calculate the total number of workers at the end of the 3 years. So this is very similar to a compound interest question that we'd have if we had a financial question. So the general formula for compound interest is A, which is the amount, in our case 25,000, multiplied by 1 plus I, the interest amount, to the power of n, the number of years. So we have A, which is 25,000 workers, I, which is the rate of increase per year, which is 6%. Now we want to make sure that we don't have our numbers in percentage signs. We have it as either a decimal place or a fraction. I'm going to do it as a decimal place, but you can have it as a fraction, which would be 6 over 100. And then we have n, and n is the number of years, in our case 3. So if we plug these values into our equation, we have 25,000 multiplied by 1 plus 0.06 to the power of 3. And if you plug that into your calculator, it should give you 29,775.4. Now you obviously can't have 0.4 of a person, and so your answer is going to be 29,775. Question 5 says, Habib has 2 identical tins. He puts 600 grams of flour into one of the tins. The flour fills the tin completely. The density of the flour is 0.6 grams per centimeters cubed. Habib puts 600 grams of salt into the other tin. The salt does not fill the tin completely. The volume of the space in the tin that is not filled with the salt is 700 centimeters cubed. Work out the density of the salt you must show all your work in. So the first thing that we need to do is we need to work out the volume of the tin. So density is equal to mass over volume. And so if we rearrange to make volume the subject, it's volume is equal to mass over density. So we know that the mass is 600. So volume is equal to 600. And the density, well, it says that the first tin was completely filled with the flour and the density of the flour was 0.6. And so our density of the tin is going to be 0.6 as well. And so if we plug that into our calculator, that gives us 1,000 centimeters cubed. So the volume of the tin is 1,000 centimeters cubed. So as both tins are completely identical, we know that the volume of the second tin is also 1,000 centimeters cubed. The question says that the volume of the space in the tin that is not filled with the salt is 700 centimeters cubed. And so we can work out the volume of the salt, and that's just the total volume of the tin, which is 1,000 centimeters cubed, minus the amount that was not filled, so 700 centimeters cubed. And so the volume of the salt is 300 centimeters cubed. Finally, we can work out the density of the salt by using this equation here. So we know that the mass of the salt used was 600 grams. The density of the salt, the volume of the salt is 300. And so 600 divided by 300 is 2. So the density is 2 grams per centimeters cubed. Question 6 says, Tim has two biased coins, coin A and coin B. He is going to throw both coins. The probability that coin A will land on heads is 0.6. The probability that coin B will land on heads is 0.55. Complete the probability tree diagram. Well, we know that probability is always out of 1. So if the probability of getting heads is 0.6, then the probability of getting not heads is 1 minus 0.6, which is 0.4. For coin B, again, if the probability of getting heads is 0.55, then the probability of not getting heads is 1 minus 0.55, which is 0.45. And for the one in the bottom, well, nothing really changes, it's the same thing. So the probability of getting heads is 0.55, and therefore the probability of getting not heads is 0.45. Part B says, Tim throws coin A once and he throws coin B once. Work out the probability that both coins lands on head. Well, because we're looking for both coins landing on heads, it's an AND probability. And so we're going to multiply. So using our tree diagram, the probability that it lands on heads for coin A is here. And then after that, the probability that it also lands on coin B is here. So it's going to be 0.6 multiplied by 0.55, and that's equal to 0.33. Question 7 says, a paddling pool is in the shape of a cylinder. The pool has radius 100 centimeters. The pool has depth 30 centimeters. The pool is empty. It is then filled with water at a rate of 250 centimeters cubed per second. Work out the number of minutes it takes to fill the pool completely. Give your answer correct to the nearest minute. You must show all of your working. Well, the first thing that we need to do is we need to work out the volume of the pool. And the shape of the pool is a cylinder, so the volume of the pool is just pi r squared multiplied by h. That is pi 100 squared multiplied by 30. And that, if you put into our calculator, is equal to 942,477.796, etc. Now, we're told that it's filled at a rate of 250 centimeters cubed per second. So it's going to be 250 is equal to centimeters cubed. So the volume at the top, which is 942,477.796 over, because per means divide, second, so time taken at the bottom. Time taken. So we're going to rearrange to make time taken the subject. And so that's 942,477.796 over 250. And if we plug that into our calculator, we get 3,769.911 seconds. Now the question is asking us to make it into minutes. So we're going to divide it by 60. And that gives us roughly 62.83 minutes. Now the question has asked us to give us answer to the correct nearest minute. So we need to round up. So that is 63 minutes. Question 8 is about vectors. A is 3, 2 and B is -1, 4. On the grid below, draw and label the vector 2a plus b. Well, 2a is just 2 multiplied by the vector a, which is 3, 2, plus b, which is just -1 and 4. 2 times 3 is equal to 6, and 2 times 2 is equal to 4, plus the -1, 4. 6 minus 1 is 5. 4 plus 4 is 8. So we need to draw the vector 5a. So we can start anywhere on our grid. Let's start here. So we need to go, this is the x-axis, this is the y-axis. So we need to go across by 5 and up by 8. So 1, 2, 3, 4, 5, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. We then just draw a straight line from our points and an arrow to show the direction of the vector. Question 9 says the diagram shows a cube and a square based pyramid. The volume of the cube is equal to the volume of the pyramid. Work out the perpendicular height h centimeters of the pyramid. Well, to work out the volume of the cube, it's just base times height times width, which is 6 times 6 times 6, which is 6 cubed, which is equal to 216 centimeters cubed. Now the formula for a square base pyramid is just the base times the height times the length over 3. And that's the volume of a pyramid. And so we can put that into our formula of pyramid is equal to 8 times 8 times our height, which is unknown, over 3. And we know that they are both equal to each other, so we can equate them and say 216 is equal to 8 times 8 times the height over 3. If we take the 3 to the other side, it's 216 multiplied by 3 is equal to 8 times h. So that's 648 is equal to 64h. Make h the subject, that's 648 over 64, and therefore h is equal to 10.125 centimeters. Question 10 says there are only red counters and yellow counters in bag A. The ratio of the red counters to yellow counters is 3:5. There are only green counters and blue counters in bag B. The number of counters in bag B is half the number of counters in bag A. Given that there are X red counters in bag A, use algebra to show that the total number of counters in bag A and bag B is 4x. Well, the first thing that we need to do is we need to work out the total number of counters in bag A, and the ratio is 3:5, and so that the total ratio is 8. Now, we know that there's X red counters, so to get the number of X or red counters, it's going to be 3/8, which is the ratio of red counters, multiplied by the total number of counters in bag A, which we'll call total A. And so if you rearrange this equation, we can get the number or total number of counters in bag A, which is total A is equal to 8/3x. Now in the question it says that the total number of counters in bag B is half the number of counters in bag A. And so we can say that the total of B is just the total of A, which is 8/3x, divided by 2. And that is equal to 4x/3. Finally, we just need to work out the total number of counters of both bag A and B. So we just add them together. That's 8/3x plus 4/3x, which is equal to 12/3x, which is equal to 4x. Question 11 says, Minna records the speeds in miles per hour of some cars on a road on Friday. She uses her results to work out the information in this table. On the grid, draw a box plot to show the information in the table. So Minna's missing a couple of things that we need to draw that box plot. We need the upper quartile and we need the maximum speed. So the upper quartile is just the lower quartile plus the interquartile range. And so that's going to be 35 plus 12, which is equal to 47. So our upper quartile is 47. To work out the maximum speed, it's just the lowest speed plus the range, because the range is the maximum number minus the minimum number. And so that's going to be 25 plus 37, which is the lowest speed plus the range, to get the, say, the upper speed. And that is equal to 62. So now all we need to do is plot the box plot. So the minimum or lowest speed is at 25. So that's going to be here. The maximum we've just worked out is 62. So that's going to be here. The lower quartile is 35. So that's here. The upper quartile is what we've worked out, which is 47, which is here. And so we can join those two together. The median is at 40. And that's all we need. So we're just going to join it up now. And that's our box plot drawn. Part B says Minna also records the speeds of some cars on the same road on Sunday. She uses her results to draw this box plot. Part B says compare the distribution of the speeds on Friday with the distribution of speeds on Sunday. So the first thing that we can note is that the median speed for Sunday is greater than the median speed for Friday. So cars in general are moving or driving faster on Sunday. So median speed for Sunday is greater than median speed for Friday. And the next thing that we can note is the interquartile range for both, i.e. the range of speeds for Friday is much smaller than the range of speeds for Sunday. So that's one point. Another point is the range of speeds, or the interquartile range, for Friday is smaller than range of speeds, or the interquartile range, for Sunday. Question 12 says the diagram shows triangle T drawn on a grid. Enlarge the triangle T by scale factor -2 with center of enlargement 0, 0. So the first thing to note is that the scale factor is a negative number, -2, which means that we're going to reflect triangle T in the opposite quadrant and then enlarge it. So it'll be in this bottom left negative quadrant. So let's start off with this point here, which is 1, 2. And so we'll enlarge it in the opposite quadrant. It will be 1, 2 on the left. So -2, -4. So that point there. This point here is 1, 3. And so if we double it and multiply by negative, it will be -2, -6. So here. And finally, this point here is 3, 2. And so multiplying both coordinates by -2 gives us -6, -4. So -6, -4, which is here. So if we draw this triangle out, it should look like this. Question 13 says there are 30 students in a class. A teacher is going to choose at random 2 of the students. Work out the number of different pairs of students that the teacher can choose. So all we need to do is say 30 multiplied by 29, because you can't pair up with yourself, divided by 2, and that should give us an answer of 435. So there are 435 different pairs of students that the teacher can choose. Question 14 says, at the start of 2022, Kim invested some money in a savings account. The account paid 3.5% compound interest each year. At the end of 2022, interest was added to the account, then Kim took £750 from the account. At the end of 2023, interest was added to the account, then Kim took £1,000 from the account. There was then £2,937 14 in the account. Work out how much money Kim invested at the start of 2022. You must show all of your working. Now, the general formula for compound interest is A, which is the initial amount, multiplied by 1 plus I, which is the interest rate, to the power of n, which is the number of years. So at the start of 2022, she starts off with A, At the end of 2022, we have A multiplied by 1 plus I, which is 1 plus 3.5%. We're going to change that into a decimal place, which is 0.035 to the power of 1, because it's at the end of 1 year. That is equal to A multiplied by 1.035. She then takes out £750 from the account at the end. So the remaining amount at the end of 2022 is just the 1.035A minus the £750 she took out the account. Now we just need to do this for 2023. So we start off with this amount here, which is our new A. Multiplied by 1 plus 0.035, again to the power of 1 because it's for 1 year. So if we expand this, it's 1.035A multiplied by 1, which is equal to 1.035A, and 1.035A multiplied by 0.03, and that's equal to 0.036225A. Then you've got negative 750 multiplied by 1, that's minus 750, minus 750 multiplied by 0.035, which is equal to 26.25. And so if we collect all the like terms, we're left with 1.0712A minus 776.25. Now, at the end of 2023, she takes out £1,000, and so we can say that the end of 2023 is equal to this amount here, which is 1.0712A minus 776.25 minus the £1,000 she withdraws. And so if we simplify this, it gives us 1.0712A minus 1,776.25. Now we know in the question that at the end she has £2,937.14, and so we can equate this to the £2,937.14. So now all we need to do is rearrange to get A, the initial amount, the subject, and that is 1.0712A, which is equal to £2,937.14 minus 1,776.25, and that is equal to £4,713.39. And so to make A the subject, we take the 1.0712 to the other side. It becomes divide. And so A, the initial amount, is equal to 4,400. And so her initial amount was £4,400. Question 15a says, simplify fully a minus 3 all squared divided by 5 multiplied by a minus 3. So if we split the top term, that becomes a minus 3 multiplied by a minus 3 all over 5 multiplied by a minus 3. We can cancel these two out, and we're left with just a minus 3 over 5. Part B says, factorize 3k squared plus 11k minus 4. So there's a couple ways we can do this. We can use the quadratic formula, or we can split the middle term. So let's split the middle term. The first thing that you need to do is you need to multiply the coefficient of k squared with c, in our case 4. So that's 3 times 4, which is equal to 12. We then need to find the factors of 12. So that's 6 times 2, or it can be 12 times 1. We then have to ask ourselves, which two pairs added or subtracted from each other give us the middle term, in our case 11? Well, that's going to be 12 minus 1. And so we can rewrite our quadratic equation as 3k squared plus 12k minus k minus 4. And as you can see, as the name suggests, we've just split the middle term 11k into 12k minus k. We can now deal with these separately. So we have this part of the equation and we have this part of the equation. And we just need to factorize both sides. So 3k squared plus 12k becomes, well, common is 3k and k plus 4 minus, and if we factorize this side, well, it's minus 1 and k plus 4. Now we can see that both sides have the brackets k plus 4, so that's going to be one part of our solution, k plus 4. And the other part of the solution is everything outside of the brackets. In our case, 3k minus 1. So that is our answer, k plus 4 multiplied by 3k minus 1. Part C says, simplify fully 4 minus x squared over x squared plus 3x divided by x plus 2 over x plus 3. So the first thing that we will notice is the numerator of our first function is the difference of two squares. So to remind ourselves, the difference of two squares says a squared minus b squared is equal to a plus b multiplied by a minus b. And so we can rewrite the numerator as 2 plus x multiplied by 2 minus x. The numerator can be factored out with x outside the brackets and x plus 3. And that's divided by x plus 2 over x plus 3. Now we know from our rules of dividing fractions is that we keep one the same, we change the sign, and we flip the second. And so if we keep our first one the same, that's 2 plus x, 2 minus x over x, x plus 3. Change the sign, so it becomes multiplication, and we flip the second fraction, that's x plus 3 over x plus 2. Now we can see that we have x plus 3 in the denominator and x plus 3 in the numerator, so they both cancel out. And we have x plus 2 as the denominator here and x plus 2 as the numerator here. So if we cancel those out, we're left with 2 minus x over x, and that's our answer. Question 16 says the functions f and g are given by f of x is equal to 12 over x plus 1 and g of x is equal to 5 minus 3x. Part A asks us to find f of minus 3. So we have our f of x function, which is 12 over x plus 1, and it's asking us to work out f of minus 3. So anywhere we find x in our function, we're going to replace with minus 3. So that's 12 over minus 3 plus 1. That's equal to 12 over minus 2, and that's equal to minus 6. So f of minus 3 is equal to minus 6. Part B says find f of g of 1. So the first thing that we need to do is we need to figure out what our function f of g of x is. So what we need to do is we need to put g of x into f of x wherever we find an x. So we're going to rewrite the function f of x as 12 over, now we have an x here, so we're going to replace that with the entirety of g of x. So 5 minus 3x. And then the rest of it is just plus 1. And so we can simplify that as 12 over 5 plus 1 is 6 minus 3x. And that is our f of g of x. Now the question is asking us to work out f of g of 1. So wherever we find an x in our f of g function, we're going to replace with 1. So f of g of 1 is equal to 12 over 6 minus 3 times 1. That's equal to 12 over 6 minus 3. That's equal to 12 over 3. And so f of g of 1 is equal to 4. Part C says find the inverse function of g where x equals 4. So first we need to find the inverse function of g. So the g of x function is equal to 5 minus 3x. We say let y equal g of x. And so we say y is equal to 5 minus 3x. And we want to rearrange this equation to make x the subject. So that's y minus 5 is equal to minus 3x. And therefore x is equal to y minus 5 over minus 3. We then replace y with x and x with, in our case, inverse function of g. So if I rewrite this out, my inverse function of g of x is equal to x minus 5 over minus 3. Now it's asking us to work out the inverse function of g where x equals 4. So anywhere I find x, I'm going to replace with the number 4. That's 4 minus 5 over minus 3. That's minus 1 over minus 3, which is equal to a third. Question 17 says, a ball is thrown upwards and reaches a maximum height. The ball then falls down and bounces repeatedly. After the nth bounce, the ball reaches a height of hn. After the next bounce, the ball reaches a height given by hn plus 1 is equal to 0.55 hn. After the first bounce, the ball reaches a height of 8 meters. What height does the ball reach after the fourth bounce? So we know that after the first bounce, the height, or h1, is 8 meters. And so to work out h2, or the second bounce, it's 0.55 multiplied by h1, which is 8. And that is equal to 4.4 meters. So we have to repeat this again. So h3 is just 0.55 multiplied by h2, in our case 4.4 meters, and that is equal to 2.42 meters. And finally, for the fourth bounce, we say h4 is just 0.55 multiplied by h3, which is 2.42, and that is equal to 1.331 meters. So after the fourth bounce, it bounces or reaches a height of 1.331 meters. Question 18 says that ABCD is a quadrilateral. The area of triangle ABC is 54 centimeters squared. Calculate the area of triangle ACD. Give your answer correct to 3 significant figures. Well, we need to work out the lengths of AD, AC, or CD. And we can use the area of ABC to work out the length of AC. So this length here. We know that typically the area of a non-right angle triangle is half AB multiplied by sine C. Well, we know that the area is 54 centimeters squared. That's equal to half multiplied by A, which is the length 17. Multiplied by B, which is AC, we don't know that, multiplied by sine C, which is sine 35. We can collect the like terms, so that's 54 is equal to 17 sine 35 over 2 multiplied by B. So if we make B the subject, we get B is equal to 54 times 2 over 17 sine 35. And if you plug that into a calculator, B, or the length AC, is equal to 11.076. So this length here is 11.076. The next thing that we can do is we can work out this angle here, CAD. we know that the total angles in a triangle add up to 180. And so if you say 180 minus 57 minus 48, and that will equal 75. So this internal angle here is 75. Now the reason why we've done that is so that now we can use the sine rule to work out the lengths of AD or DC. Now the sine rule is A over sine A is equal to B over sine B, which is equal to C over sine C. And so we can pick any one of our angles and the lengths, but we have one of the lengths of 11.076, so that's the one we're going to use. And so we can say 11.076 is equal to its opposite angle, which is sine 57, which is equal to B, an unknown, over sine 48, with B being length AD. And so we can rearrange to make this be the subject, or length AD the subject, which is 11.076 multiplied by sine 48 over sine 57. If you put that into a calculator, the length AD is 9.814 centimeters. So AD is 9.814 centimeters. We can then use our area of triangle half AB sine C to work out the area of ACD. So area of ACD is equal to half multiplied by A, which is 11.076, multiplied by B, which is 9.814, multiplied by sine 75. If we put that into our calculator, we get 52.498. Now the question has asked us to give our answer to correct to three significant figures, and so the answer is going to be 52.5 centimeters squared. Question 19 says R is equal to P over Q. P is 5.88 times 10 to the power of 8, correct to three significant figures. Q is 3.6 times 10 to the power of 5, correct to two significant figures. Work out the lower bound for R. Give your answer as an ordinary number, correct to the nearest integer. You must show all your working. So the first thing that we need to know is we need to make R as small as possible, as we're looking for the lower bound for R, which means that we want the lower bound for P because we want the numerator as small as possible over the upper bound of Q. So a large denominator and a small numerator gives us a really small number. So if we work out the lower bound of P, that's 5.88 times 10 to the power of 8. We always look at the next significant figure here and we go down by 5. And so that becomes 5.875 times 10 to the power of 8. To work out the upper bound of Q, we're going to do a similar thing. That's 3.6 times 10 to the power of 5. We look at the next significant figure, in our case the third one, and we go up by 5. And so that becomes 3.65 times 10 to the power of 5. We know that the equation for R is P over Q, and so we plug in our values. We have our lower bound of P, which is 5.875 times 10 to the power of 8, divided by our upper bound for Q, which is 3.65 times 10 to the power of 5. And if we plug that into our calculator, we get 1609.589. Now the question has asked us to write our number to the nearest integer, that means the nearest whole number, and so that is equal to 1610. Question 20 says x minus 4, x plus 2, and 3x plus 1 are consecutive terms of an arithmetic sequence. Find the value of x. Well, we know with arithmetic sequences, the difference between each term is always the same. And so if we write out our sequence, it's x minus 4, x plus 2, and 3x plus 1. And we'll number the terms. So this is term 1, term 2, and term 3. Well, the difference of 2 minus 1 is the same as the difference of 3 minus 2. So let's work that out. So the difference for the first two terms, so 2 minus 1, is x plus 2 minus x minus 4. That's x plus 2 minus x plus 4, and that's equal to 6. For term 3 minus term 2, the difference is equal to 3x plus 1 minus x plus 2, 3x plus 1 minus x minus 2, and so the difference is 2x minus 1. Now, as the difference for both are the same, we can equate them, and so we can say 2x minus 1 is equal to 6, 2x is equal to 6 plus 1, 2x is equal to 7, and taking the 2 to the other side, we have x is equal to 7 over 2. Part B says y minus 4, y plus 2, and 3y plus 1 are three consecutive terms of a geometric sequence. Find the possible values of y. Now, when dealing with geometric sequences, the difference between each term is a common difference. And so if we write out our sequence, it's y minus 4, y plus 2, and 3y plus 1. And our terms are term 1, term 2, and term 3. And so what we can say is that the common difference of 2 and 1 is 2 over 1, and that's equal to the common difference of 3 over 2. And so if we write that out, that's y plus 2 over y minus 4, and that will be equal to the same for terms 3 and 2, which is 3y plus 1 over y plus 2. So as they're equal, we can equate these two equations together. Y plus 2 over y minus 4 is equal to 3y plus 1 over y plus 2. We can rearrange this equation so that's y plus 2 is equal to 3y plus 1 y minus 4. We can expand this, so y times y is y squared, 2 times y is 2y, 2 times y is also 2y, and 2 times 2 is 4. That's equal to 3y times y, which is 3y squared. 3y times minus 4 is minus 12y. 1 times y is y, and 1 times minus 4 is minus 4. We can clean this up, so we are left with y squared is equal to, y squared plus 4y plus 4 is equal to 3y squared minus 11y minus 4. You'll notice that if we rearrange this, we can turn this into a quadratic equation. So if we collect all the terms onto one side of the equation, we have 3y squared minus y squared minus 11y minus 4y minus 4, and minus 4. And that's equal to 0. And so if you collect all the like terms, we're left with 2y squared minus 15y minus 8 is equal to 0. Now, to factorize this quadratic, we can use the quadratic formula, or we can use splitting the middle term, as we did previously in question 15. Our middle term becomes 2y squared minus 16y plus y minus 8. So we split minus 15y into minus 16y plus y. We then need to just factorize this part and this part, and that becomes 2y y minus 8 and plus 1 y minus 8. And so we can collect the terms outside, and that becomes 2y plus 1 and y minus 8 is equal to 0. So we know either this term here is equal to 0 or this term here is equal to 0. So if we say that 2y plus 1 is equal to 0, 2y is equal to minus 1, and so y is equal to minus a half, or y minus 8 is equal to 0, and therefore y is equal to 8. And so our two values are y is equal to minus 1/2 or y is equal to 8. Question 21 says, the diagram shows a circle radius r centimeters and two regular hexagons. Each side of the larger hexagon ABCDEF is a tangent to the circle, and each side of the smaller hexagon PQRSTU is a chord of the circle. By considering perimeters, show that pi is greater than 3 but less than 2 root 3. So we need to consider perimeters, and they've told us they are regular hexagons, and so we know that the sides are equal. And so the perimeter of both hexagons is just 6 times the number of the length of the sides, which we'll call x for now. And we know that the perimeter of a circle is just 2 pi r. So let's deal with the smaller hexagon first. We have a center O, and so we can draw our radii like so. And as these are equilateral hexagons or regular hexagons, we know that the internal angle is going to be the same for all of them, which is 60 degrees, and so on. And each of these lengths are lengths r, or radius. Now, again, as these are regular hexagons, that means that the internal triangles are all equilateral triangles, and so these angles here are also 60 degrees. And so again, as these are equilateral, this is also r, and the outside length is r. And so the perimeter of the smaller hexagon PQRSTU is just 6 times by the radius r. Now we need to work out the perimeter of the larger hexagon ABCDEF. So if we clean up our diagram, now if we redraw our center O and we draw a radius from the center that meets the tangent, we know that that angle is 90 degrees. And this is the radius. And so we can form a right angle triangle. Now, similarly to before, we can split the shape up. And so we can draw a radius to the tangent. Like so. Similar to before, we have equal triangles. And so the internal angle is going to be 60 degrees again. And so if that's 60 degrees, then this is going to be 30 degrees, as is this. Now, we previously drew this right angle triangle, and so we can work out this internal angle here. And that's just going to be 180 minus 90 minus 30, which is equal to 60. And so this angle is 60 degrees. Now, this is a special kind of right angle triangle. Right, so if that's 90 degrees and that's 60 degrees and that's 30 degrees, this has a ratio for angles of 30 to 60 to 90. And it has special properties whereby they have a ratio of, for the lengths of x to x multiplied by root 3 to 2x. And so if we know that this length here, the one opposite 60 degrees, is r, that means this is going to be r over root 3. And this is going to be 2r over root 3. And so if this bottom line is r, that means this one here is r over root 3. And that is this length here, r over root 3, which is half the length of AB, which means this part here is also r over root 3. And so the entire length of one of the sides, or for example, side AB of the larger hexagon, is just 2r root 3. And so to work out the perimeter of the larger hexagon A, B, C, D, E, F, it's 6 multiplied by 2r root 3, which is 12r root 3. And so we have three expressions, one for the perimeter of the circle, which is 2 pi r, one for the perimeter of the smaller hexagon, and one for the perimeter of the large hexagon. And so we can create this expression in terms of the sizes, which is the larger hexagon, which is 12r over root 3, which is greater than the perimeter of the circle, which is 2 pi r, and that is greater than the perimeter of the smaller hexagon, PQR-STU, which is 6r. Now, we want to get rid of the root 3 in the denominator of the perimeter for the larger hexagon, and so we're going to rationalize that, which means we need to multiply the top and bottom by root 3. And that will equal 12 root 3r over just 3. And so we can rewrite this inequality at the bottom as 6r is less than 2 pi r, which is less than 12 root 3 over 3r. That will simplify to 6r is less than 2 pi r, which is less than 4 root 3r. Now we need to show that 3 is less than pi, which is less than 2 root 3. And so we're going to divide the entire inequality by 2r. And that will give us, so dividing by 2r. And so we are left with 3 is less than pi, which is less than 2 root 3. And that's our answer. And that brings us to the end of the paper. Thank you for watching. I hope that helped. I hope that was easy to follow and you understood how we tackled each and every question. Please feel free to leave a comment below to let me know if this helped and if you have any further questions. Make sure to like, share and subscribe and hit that notification bell.